Hello everyone. Today we're going to talk about a super interesting topic, robotics. My name is Judy and my Chinese name is Yao Zhou.
My name is Zoe and my Chinese name is Sizhe Liu.
My name is Nora and my Chinese name is Siyun Gu.
Three of us will share with you around three key aspects: how robots are built, the brains behind them, and what the future might hold. When we imagine a robot, many of us still picture those big metal arms in car factories, or maybe even scientific movie characters. But today's robots are so much more, and what makes them truly amazing isn't just their bodies, but how their brain, senses, and body learn to work together. First, let's talk about the brain. I like to imagine a robot, artificial intelligence, as the conductor of an orchestra. It doesn't play every instrument, but it tells everyone what to do and when to do. Programmers don't just type commands. They build smart systems that help robots understand speech, recognize objects, and even learn from mistakes. It's like teaching a kid step by step, then get smarter. Then come the senses. A robot camera doesn't just take pictures, it can measure depths. Its microphone doesn't just record, it can filter out noise to catch your commands clearly. There are even sensors that let robots feel texture or pressure. Think about surgical robots that can tell the difference between muscle and tissue. Amazing, right? It's this real sensing that lets robots work safely alongside humans. And finally, the body. This is where motors come into play, like artificial muscles, helping robots moving smoothly and accurately. The body follows the brain's commands again and again until the movement becomes natural. So, when these three systems, brain, senses, and body, come together, robots are no longer just machines. They become our helpers or partners. But here's a question. Who teach them to do all of this? Well, that's exactly what we'll explore next.
Engineers design the robot's body, while programmers design its intelligence. This intelligent system operates in a continuous cycle. First, a robot needs to know what's around it, just like we use our eyes and ears. A robot uses its sensors. Cameras act as its eyes, microphones as its ears, and other sensors help it feel the world. These sensors collect a lot of raw data, but this data is just noise, a mess of shapes and sounds. That's where artificial intelligence comes in. Artificial intelligence acts as the robot's brain. It makes sense of all this information. So, the robot doesn't just see a round, red object. It understands this is an apple. It doesn't just hear sound. It understands the command, please open the door. Knowing something is there is one thing. Knowing what to do about it is another. This is where planning comes in. To move from seeing to doing, the robot uses smart algorithm. Think of it like this. If you ask a robot to pick up a bottle, it doesn't just reach out. It first has to find the bottle, then figure out how to move its arm without hitting anything, and finally decide how to grab it firmly. So the robot breaks these big tasks into small, easy steps. It's like the robot creates a to-do list in its head before it makes any move. Now, here's the most exciting part, machine learning. In the past, we had to program robots for every single situation. What if the bottle is on its side? What if the path is blocked? It was impossible to plan for everything. But today, robots can learn by themselves. One way is through virtual simulations. A robot can practice walking in a computer world, falling down millions of times without ever getting damaged. From every mistake, it learns and gets better. Another way is through real practice. A robot can try picking up different objects and learn the best way to hold them. This means robots are no longer just following strict orders. They are improved on their own and handle new situations they were not specifically programmed for. All of this leads to the robot's most useful skill, adaptation. This is where the whole cycle comes together. Let's say a robot is walking and finds a chair blocking its path. It will not just stop or crash into it. It will use its sensors to see the chair. Then its planning system will quickly find a new path around it. And thanks to its learning ability, it might even remember how it solved a similar problem before. So it adapts to the change and succeeds. So the real goal is not to build robots that replace humans. The real vision is to create machines that can work effectively and safely alongside us. We want them to be our partners, to help us in factories, in our homes, and in dangerous places. In the end, we are building technology that understands, adapts, and collaborates with people, and that's the future worth building together. Robots aren't just tools. They become part of our communities. That means we are all connected to how robots grow and where they are used. So today I want to talk about 4 things that are deeply personal to all of us: our jobs, our safety, our fairness, and the future we will share. Let's start with jobs. Robots are taking over some tasks, especially in manufacturing and logistics. But history shows us that technology also creates new jobs. When ATMs were introduced, people feared bank tellers would disappear. Instead, banks hired more people for customer service and advisory roles. So the key is training. We need to focus on skills robots don't have, like creativity, teamwork, and strategic thinking. Then it's safety and responsibility. As robots enter our homes, streets, and workplaces, we need clear rules. Think about self-driving cars. If one gets into an accident, who is responsible? the maker, the programmer, or the owner. Countries like Germany and Japan are already drafting laws that clarify this. We should do that too. Good regulation doesn't slow innovation. It builds trust. Then there is fairness. Robots learn from data, and that data can contain human biases. A famous example is when hiring robots at a big company started favoring male candidates because it was trained on years of biased hiring data. That was scary. So we must regularly check their decisions and make sure they are fair to everyone, regardless of gender, race, or background. And finally, the big question: what kind of future do we want? Robots can be amazing helpers, especially in areas like elderly care or education. But they shouldn't replace human connection. I recently read about a nursing home that used companion robots. They were great for reminders and simple chats. But what the residents really loved was when real people visited. So it's up to us. Technology is a tool, and we decide how to use it. Let's ensure that the future we build is one in which robots assist us in becoming more human. In the end, I would like to give a conclusion about what we have talked about today. Robots are like our companions. They have intelligent brains, sensitive senses, and flexible bodies. The brain enables them to think. The senses enable them to see and hear. And the body makes them move. The most exciting thing is that they keep learning and making progress, so they can perform better in dealing with tasks through practices and simulations. And in the future, these robots will not only replace simple jobs, they will become our great assistants in both daily life and workplaces. Despite the challenges still remain, they will work together with us to create a smarter, more efficient, and brighter future for everyone.